All right, welcome back to another set of flipped classroom notes. Recently, we have been looking at triangle similarity. We have gone over our side similarity theorem. We have covered our angle similarity theorem. And now today, we are looking at our side similarity theorem. So in order to tell if two triangles are similar, using our side theorem, we need to know if our two pair of corresponding sides are proportional. Okay, they have to be proportional, and the included angles must be congruent. Okay, if this is the case, then we know that the triangles are similar. Okay, so in order to check for side similarity, I first need to identify the two pairs of corresponding sides. Afterwards, we write and compare the ratios. Then we check that the included angles are congruent. If both of these conditions, meaning our sides are corresponding and the ratios are the same and our angles are congruent, then we know the triangles are similar. Okay, we're going to take a look at two examples here. I'm going to first start by figuring out which sides are corresponding. And because I don't have a similarity statement to do that, I'm going to take the largest side from each triangle because they should both be corresponding. So I have 50 over 35, and I have 45 over 31 halves. Okay. So I'm going to go ahead and I'm going to simplify both of these. I know 50 and 35 are both divisible by 5, so I get 10 sevenths. And I know that 45 and 31.5 are also divisible by 5. So I get 9 over, let's see here, 6.3. So my ratios don't look similar. But I'm going to check it one more way first. I'm going to set my two ratios equal to each other. I'm going to go 10 sevenths is equal to 9 over 6.3. I'm setting my simplified ratios equal to each other because it's smaller numbers to work with. Because if I multiply 6.3 times 10, I get 63. And if I multiply 9 times 7, I also get 63. I just cross multiplied. And these two numbers are the same, so I know that these ratios are equal. Okay, they are proportional to each other. So just because when you simplify your ratios, they aren't the exact number, double check it using cross multiplication. If you prefer to just set your first two ratios equal to each other and cross multiply, you absolutely could, because you would still get two values that are the same, just much larger numbers. Okay, so they both work whether you cross multiply your simplified values or your larger numbers. So my two triangles are similar, okay? And my statement would be triangle FGE is similar to triangle KHJ for number 1. Number 2 looks like it's only one triangle, but again, it's 2. So I'm going to go ahead and I'm going to separate my two triangles. If you notice, angle L has a congruency mark. And that is because even when I move angle L, there's still one there. So angle L is congruent to itself. So I'm going to go ahead and write out my values. So I have segment XL is 30, segment YL is 27, segment GL is 39, and segment BY is 34. So just like before, I'm going to take my larger two values for my proportions. I have 39 over 30, and I have 34 over 27. I'm going to go ahead and simplify both of these first again. 39 and 30 are both divisible by 3. So I get 13, and I get 10. And then below I have 34 and 27. 27 is only divisible by 9 and 3, but 34 isn't divisible by either of those. So I can't simplify 34 over 27. So in order to double check if they're similar or not, I'm going to go ahead and I'm going to cross multiply like before. But I'm going to use my whole numbers or my unsimplified versions because I wasn't able to simplify both fractions. So when I multiply 39 times 27, I get 1,053. And when I multiply 34 times 30, I get 1,020. These values are not the same, so my two triangles are not similar. Please write at least one question you still have about today's notes, and have a great afternoon.